When we say that the velocity of an object is relative, what we mean is that its velocity depends on your point of view. And every person or object has their own point of view on things. In physics, we call a particular point of view a reference frame. So here are two objects, a car and a tree. Each one has its own reference frame. The tree's reference frame, the car's reference frame. So in the tree's reference frame, well, the tree thinks that itself is not moving. From the tree's point of view, its own velocity is zero. That's always true. In your own reference frame, from your point of view, you are not moving. It's everything else that's moving around you. So from the tree's point of view, it sees the car moving to the right in the positive direction, let's say, at a speed of 25 meters per second. What we say is that the velocity of the car relative to the tree is 25 meters per second. We could replace these words with the words from the tree's point of view. Relative to the tree means from the tree's point of view. So the velocity of the car relative to the tree is 25 meters per second. Now from the car's reference frame, in the car's point of view, the car is not moving. You're in your car, you think you're not moving, and the whole world is moving around you. So the velocity of the car in the car's reference frame is zero, even though it was 25 meters per second in the tree's reference frame. So in the car's reference frame, what it instead sees is that the tree is moving at a velocity of negative 25 meters per second. That's the velocity of the tree relative to the car. That means the velocity of the tree from the car's point of view. Let's look at another scenario. Okay. Here we have Dr. Jones riding a horse on top of a submarine, firing a bullet from a revolver at a Nazi officer who's jumping off the submarine into the water. So we have 5 different points of view in this scenario. The point of view of Dr. Jones, of the submarine, that is, of someone standing at rest here on the submarine, point of view of the Nazi officer, point of view of the water, or of someone who is just bobbing up and down at rest in the water, and also the point of view of the bullet. Imagine being tiny and crouching on this bullet and riding it. You would have your own point of view. So 5 different points of view here. I've highlighted the submarine to indicate that we are currently in the submarine's reference frame. So this is the situation from the point of view of the submarine. So if you were standing here on the deck of the submarine, not moving, this is what you would see. Jones moving to the left, that'll be the negative direction, at negative 8 meters per second. So Jones is riding this way, the Nazi officer is jumping off, moving to the left, negative 3 meters per second, and you see the water moving by the submarine at a speed of negative 10. Okay. So with this information, we want to then switch over to Jones's point of view. Here's the same scenario, but I've highlighted Dr. Jones to indicate that we are now in Dr. Jones's reference frame. And the information he has is that the bullet leaving the revolver is moving at a speed of negative 300 meters per second relative to Dr. Jones. So from Jones's point of view, that's the speed of the bullet. Okay, the only thing we don't know up here is the speed of the bullet from the sub's point of view, but we can figure that out. We'll come back to that in a bit. Let's first look at the speed of these other objects from Jones's point of view. Okay, the speed of the submarine itself. Well, from the sub's point of view, Jones is going 8 meters per second that way. So if we then were to freeze Jones and imagine we're Jones, we know that the whole submarine is moving to the right from Jones's point of view. So from the sub's point of view, Jones is moving left at negative 8. Therefore, from Jones's point of view, the sub must be moving to the right at 8 meters per second. Okay, how about the water from Jones's point of view? Let's compare here. Jones is going at negative 8, the water is going negative 10. So the water is going faster this way than Jones is. So Jones should see the water overtaking him. The difference in their speed is 2 meters per second. So the water is going faster than Jones at a difference of 2 meters per second. Therefore, from Jones's point of view, he sees the water flowing by at 2 meters per second. Okay, how about the Nazi from Jones's point of view? Jones is riding this way at -8. Nazi's going this way at -3. So compare their speeds. Jones is going faster than the Nazi. Therefore, Jones is going to overtake the Nazi. Jones is going faster than the Nazi here. So from Jones's point of view, he should see the Nazi coming towards him. The distance between them is decreasing, but Jones doesn't think he's moving. He thinks the Nazi is coming towards him. Just like in the car, he felt that the tree was coming towards the car. So the difference in their speeds, this is what you want to do, compare the difference. It's a difference of 5. That's -8, that's -3. The difference is 5, therefore from Jones's point of view, he should see the Nazi coming towards him at 5 meters per second. Okay, and that's the velocity of all 4 other objects relative to Jones. In Jones's view of the world, the bullet's going that way, the sub and the Nazi are coming towards him, and the water is very slowly moving this way. Now we can go back and figure out the speed of the velocity of the bullet from the sub's point of view. Since Jones sees the bullet moving 300 meters per second that way, the difference between Jones's speed and the bullet's speed is 300 meters per second. We know that's the difference. So up here, when Jones is moving at -8, he still must see the bullet moving 300 meters per second faster than he is. So if Jones is moving -8 and the difference is 300, the bullet must be moving at -308. Obviously, we can't quite be to scale here. But let's look at that here. From the sub's point of view, Jones is -8, bullet is -308. From the sub's point of view, the difference is 300. From Jones's point of view, the difference is 300. The difference has to be the same from both points of view. Okay, let's switch now to the water's point of view. Let's see if we can figure that out. So I've highlighted the water. Now we're in the reference frame of the water. Now the water thinks itself is at rest in its own frame. So the velocity of the water here is 0 in its own frame. Oh, I made one mistake here. This should be a -2 meters per second. That's moving that direction. That's -2. Okay, so in the water's frame, what's the speed of these different things? Well, we already know that from Jones's point of view, the water is moving 2 meters per second this way. It's overtaking him. Therefore, from the water's point of view, it should see Jones moving this way at 2 meters per second. So if you're at rest in the water, you would see Jones moving 2 meters per second that way. Now that seems confusing at first because you know Jones is riding his horse to the left, but the whole sub is moving to the right at 8 meters per second. So the whole sub is moving to the right. Therefore, it's carrying Jones this way, even though Jones is moving that way from the water's point of view. Okay, from the sub's point of view up here, the water is moving this way at 10 meters per second. Therefore, if you're in the water, you see the sub moving that way at 10 meters per second. So from the water's point of view, we should have the sub moving at 10 meters per second that way. So if you're in the water, sub's moving that way, and Jones is being carried along with it. Note again that the difference here between Jones and the sub is 8 meters per second. That has to be the difference between them in all reference frames. So in Jones's frame, he's 0, and the sub is 8. That's a difference of 8. In the sub's frame, Jones is 8, the sub is 0, difference of 8. Differences have to be the same in all the frames. Okay, so we just need the velocity of the bullet and of the Nazi from the water's point of view. Let's take a look at the bullet. Again, we have to compare differences. We know that the difference between the bullet's speed and Jones's speed should be 300. So here, if Jones is moving this way at 2 meters per second, and we know the bullet is moving away from Jones at 300, Jones is going this way too. Therefore, the bullet has to be going this way at less than 300, at 298. Therefore, that's 298, and he's moving to the left. That's 2 to the right. The difference between them is a full 300 meters per second. The bullet is not as moving. Let's see, in the water's point of view, the bullet is not moving as fast because Jones is being carried off this way. Jones is like falling backwards as he shoots the bullet. So it's less than 300 from the water's point of view. Lastly, the Nazi. Now, compare the Nazi and Jones here. We know the difference between their speeds has to be 5 meters per second. From Jones's point of view, the Nazi has to be moving this way at 5 meters per second. Therefore, if Jones is moving this way at 2 meters per second, the Nazi has to be sort of chasing after him. The difference between their speeds has to be 5. So the Nazi must be moving this way at 7 meters per second. That way the difference between them is 5, and the Nazi is approaching Jones. Difference between them is 5, Nazi approaching Jones. Here again, difference between them is 5, and the Nazi is approaching Jones, or Jones is overtaking the Nazi. They're coming closer together. Okay, we got the speeds of all of those compared to the water. Now a couple exercises for you. I want you to take the same scenario, and now you work out all the speeds of the other 4 objects with respect to the Nazi, and then take all the speeds with respect to the bullet. So work it all out from the Nazi's point of view, from the Nazi's reference frame, and then from the bullet's reference frame. Pause the video, take a moment to work that out, and I'll show you this answer first. Ready? Okay. Here are the velocities in the Nazi's reference frame. Pause the video again, work out the bullet's reference frame. Ready? Here are all the velocities from the bullet's reference frame. Note, in the bullet's point of view, pretty much everything is zooming off to the right at or around 300 meters per second.